Everybody say hi, Lacey!
Hi, Lacey.
There was a few more, okay. All right, so Lacey, this is Monday.
No, you didn't. I will stab you in the knee with this pencil if you don't do it next time.
There is no next time.
Maybe we'll say bye, Lacey, at the end. Everybody say bye, Lacey. Okay, we'll do that when you're all warmed up and stuff, okay? So, this is Monday morning. Great. 07. I told them I've only had like a little bit of coffee today, okay? So, I'll try to get through this without falling asleep. 07, congruent and similar figures. Here's the lowdown, all right? You have figures that are called congruent, okay? And if you want to know I'm missing a U. Congruent, just look at that word down below there, whatever. And then you have similar, okay? Not all figures are one or the other. Sometimes you have a figure that's not congruent or similar, right? Congruent versus similar. Here are the differences, okay? If you want to know the big kid terms for congruent, this is the symbol that we use in geometry for congruent. Congruent. Oh, Lacey, you're going to already know this because we've done this before, okay? So congruent and similar is just the little squiggly, okay? Those are the symbols that we use. Oh, they're right here. It's like an equal sign with a little tilde over top of it. Is that a tilde in Spanish class? Come on. Okay, and then versus just the no equal sign, okay? So congruent. Two things are congruent if they are the same shape and same size. Okay, so same shape, same size. I'm going to try to draw two things that are congruent. Don't laugh at me. Those are not bad. Those are pretty well congruent, those two circles. Those are the same shape and they are the same size, and we are good to go on that. Okay. Now, similar figures are same shape. You want to take a stab? Different size. Different size. Okay. So here's one circle, here is the other circle. They are the same shape, but they are different size. So those two figures are similar to each other, but they are not congruent, okay? You see similar figures all the time when you're looking at drafts and stuff of houses, okay? My husband looks at these all the time, drafting houses, okay? When he builds a house, they don't get a big old fat sheet of paper that's the size of the house, right? They scale it down, and so that you have like this map of the house and what the house looks like that all fits on one sheet of paper, right? Those are similar figures. The actual house and the house on the paper, those are similar to each other. They're not the same size, right? Then you have to have a big old sheet of paper that's the same like size as the house that's being built, and we don't have paper that big, right? Okay. So they scale it down, that would be a similar figure. So similar versus congruent, same shape, same size, same shape, different size. Now, if I have this going on, okay, those are not similar or congruent. So you can have things that are not similar versus and not congruent at the same time. Right? They don't have to be one or the other. Right? Okay, so we're starting with congruent. Figures have the same shape, same size. There we go. These two figures are the same same shape, same size, even though I've turned one of them. Right? One of them is laying differently than the other one. That's great. The reason why I know that they are the same, you'll see this in geometry class a lot next year. You see B has like one little circle on it, one little loop. You can make this darker with your pencil. And which F has one little loop. Okay. Now A has two little loops, and E has two little loops. And C has three little loops, and D has three little loops. That means those correspond to each other. So C is exactly the same number of degrees as what D is. So if C is 50 degrees, so is D. All right? If A is 70 degrees, so is E. How many degrees does F have to be? Do we know? What? 60. How do you know that? Your brain. What do they all have to add up to be?
180.
180, right? Okay, so 50 and 70 is 120, so that means 60 degrees is what this one is, and they both have to be 60s, yeah? Okay? Now, in addition to that, you also have the little tick marks. Do you see the little ticks? This has one tick mark, this has one tick mark. This has two tick marks, this has two tick marks. This one has three, this one has three. Okay? That just shows you which sides go with which sides, all right? So you will write it like this. Your congruent angles. A is congruent to E. B is congruent to F. C is congruent to D. I was going through really, really fast. Then you have your sides. AB is congruent to EF, BC is congruent to FD, AC is congruent to ED. Okay, so here we go. Congruent statements, all right? So if you can't see the little tick marks here and here, that's what those are. B is here, it has 2 marks. This one has 2 marks. A has 3 marks. D has 3 marks. Okay, now we're going to do our angles over here. A-N-G-L-E-S. It says the corresponding parts of 2 congruent triangles are marked in the figure. Write a congruent statement for the triangles. We're going to do which angles correspond to which ones also. So we're going to do the angles, we're going to do the sides, and then we're going to do something else. Okay, angles. So which angle goes with, let's say, A? Angle A is congruent to what angle? D. Okay, angle B is congruent to angle. What one does B go with? E. Okay, now we have to be really careful about angle C. There are technically 2 angle C's. So we can't just call it angle C and angle C. When you have basically one spot that could be 2 different angles, you have to name it with 3 letters, okay? So we're going to call it angle ACB is congruent to angle. So we did ACB. That means I'm talking about this guy right here. You see that? ACB. That guy.
CD.
Okay? Now, the C has to go in the middle. So we're calling this one ACB. Okay? So, how are we going to name the other one? DCE. Can we name it ECD? Technically we can, but you usually try to go with what ones go with the other ones. So like A and D go together. So you started ACB. We want to start with DCE. Does that make sense? Because A and D go together. So we listed A first. We want to list D first. Okay? It's technically not wrong, but later on it will be. Okay? So DCE. Yeah? All right, then we do the side. So we have side. Let's do side AB. Let's do side BC. And let's do side AC. Is congruent to, congruent to, congruent to. Holy cow. All right, AB is congruent to. AB is this side right here.
DE.
DE. A goes with D, so if A is listed first, D needs to be listed first. D, E. Okay? BC. BC goes with, what'd you say? EC. We got a lot of weird letters that I have to like. E for egg or B for boy. Okay? AC is the last one. BC. Does that make sense? So we're showing that those all correspond to one another. Okay, that's not even what the question asked, but I wanted to do that once just so that you can see. They want a congruence statement. So they did not want any of that. Here's what a congruent statement looks like. Triangle ABC is congruent to triangle what? This is what they want. Triangle ABC is congruent to triangle D, what? She says DCE. DEC. It's got to go in order. Okay? A goes with D. B goes with E. C goes with C. So it's got to go DEC. Right? Does that make sense? That's what they wanted. Okay? But just to show you that each part goes with each part, we did all that other stuff too. Okay? So you don't have to do this on your homework. They're just wanting this. Right? Okay? Then I have all that background information and you're an expert. You're good to go. Okay? All right, now similar. We've already said similar is same shape, but different size. Different size or not the same size, right? Same shape, different size. Okay, so here's the deal for similar. I'm going to write over here. For similar, angles are the same. Okay? So even though we're talking about same shape, different size, your angles will still be the same measure like congruent. Like congruent. Okay? So incongruent, your angles were the same measure. Like we had a 70 and a 70, and a 60 and a 60, and a 50 and a 50. Your angles will still be the same measure. Yeah? Yeah. Only your sides will be different. Okay? So A will still be the same as D. You can see that one little tick mark. So let's say A is 50 degrees. D is also going to be 50 degrees. Okay? C has 3 tick marks. Let's say C is 30 degrees. F is going to also be 30 degrees. If E is, what's E have to be? 100 degrees. Then the other one has to be 100 degrees. So your angles stay exactly the same. The thing that changes is your sides. So we have 4, 6, and 8. 4, 6, 8. I'm just making them bigger. Then we have 2, 4, and 3 on this one. Okay, and here's how this works. You know that they are similar because if I make proportions, 4 over 2, 4 divided by 2, those two go together, has to be the same as 6 divided by 3, which is the same as 8 divided by 4. You see where I'm getting these numbers from? The sides. If I do this side over this side, and this side over that side, and this side over that side, all of those have to be the same number. Are they all the same number? 4 divided by 2, 6 divided by 3, 8 divided by 4? They all result in 2. If they do not, it's not similar. Right? You have to do that. So they all equal 2. So yes, similar. So in example 2, determine whether the polygons are similar, justify your answer. What does this mean? What's that little box mean in the corner? That's a right angle. How many degrees is a right angle? 90. Each one of those are 90. 90, 90, 90. Right? Okay? So, are those two figures similar to each other? No, why not?
The angles.
The angles have to be exactly the same. Angles have to be the same. So, no. Angles not same. Angles are not the same. So we don't even have to check the sides because we already know it's not similar. We don't care. Okay? Technically, the sides are proportionate, but the angles are not the same. So we're done. When do we get out of here? Oh, 8. Period 5. No, this is a long period, isn't it again, still? Oh, yeah. Oh, yeah. Okay. All right. Whatever. What? No, I just mean you're sitting in the same spot for like an hour. Okay. Not that I would love to have you guys for an hour. I'm glad I have you guys instead of some of my other ones. My trig class, glad I don't have them for an hour. Oh God, Lacey's in trig. Sorry, I'm not talking about you, Lacey. Whoops. Whoops. I love my trig kids. I love them all a whole lot. A whole lot. Okay, example 3. Let's keep going. Okay. Maybe she didn't watch this video. Maybe she stopped watching. Let's go with that. All right. I guess we'll know if she comes back and she's like, you yelled at all the trig kids. Whatever. Okay. Oh man, that was bad. That's real bad. All right. Solve a problem. Cadence and trig. Cadence and trig. That tells you all you need to know. Cadence and trig. All right. The city of Mansfield plans to build a bridge across Pine Lake. That's this guy right here. That's the lake. Pine Lake. That's where the bridge needs to be built, right here. And use the information in the diagram at the right to find the distance across Pine Lake. Okay, so we have this guy going on right here, and that's 55. This is 100. This is 120. So we have to use similar figures of some sort. Right? You see this little tiny triangle right here? This little tiny one. That is 100, and what's the side? 55. Then we have the big old fat triangle, which is all the way through here, and this is what we're trying to find, right? Okay, how long is the top? 120, not quite. 220. If you add both of them together, it has to be this one and that one. 220, 220. Yeah? Okay, now I don't know what this guy is, but let's give him a thing. What can we call him? The question mark guy. What do you want to call him? Sure, X. If we don't know something, we always put a variable in it. That's how math works. We put an X in. Okay, so how do I figure out what X needs to be? Do you remember this back from Algebra 1? Or
No.
what? No. you set up a proportion? A proportion is this. Something equals something. So like 55 over x equals 100 over 220. And then you cross multiply and divide, right? Okay. Now before we do that, we could have set up that proportion a little bit differently. We could have done something else, right? Instead of doing 55 over x and 100 over 220, right? We could have done 55 over 100, right? Instead, does that make sense? Okay, if we go 55 over 100, what's the other one have to be? X over 220. Okay, here's what's illegal. Here's what I cannot do. I cannot go 55 over x equals 220 over 100. I cannot do that. Watch. 55 over x equals 220 over 100. I can't do that. If you're going top to bottom, you have to go top to bottom. Does that make sense? If you're going left to right, you have to go left to right. Yeah? So do not do this. You need to make sure you're going the same direction. Does that make sense? So now, it doesn't matter which one of those I solve because no matter what, I'm cross-multiplying. I'm taking 55 times 220. I'm taking 55 times 220. Yes. I'm doing x times 100. Am I still doing x times 100? Yes, so it doesn't matter which one you use because you're end up doing the same thing. So let's start with this one. 55 times 220. I'll write it all out. This is like the easiest thing to do in like Algebra 1, I feel like. This is nice. We like this, right? Maybe not? Okay. X times 100. So what is 55 times 220?
12,100.
12,100. And 100x. Okay, don't use a calculator. I'm trying to solve for x. How do I get rid of the 100? Divide. That's where the cross multiply and divide comes in. Okay, don't use a calculator. Divide by 100. Divide by 100. Okay, when you're dividing by tens or hundreds or whatever or thousands, just cross off the zeros, right? Okay. So if I cross 0, what's x equal to? 121. Okay, 121 what? Meters. 121 meters is how long my bridge is going to be. Okay? Now, people legit do this. Like, they legit use, like, proportions like this to try to figure out how long the bridge is, because I don't want to wade the water with a tape measure to try to figure out how long that bridge is going to be, right? I don't want to do that. Okay, now, some bridge somewhere, I'll have to look it up, because somebody screwed up real bad. When you're building a bridge, right, you don't start in the middle and work your way out, right? You start at the two ends and you work your way in, and hope and pray to God that they meet up in the middle. Okay, somebody was off on their calculations. I'll have to look up what bridge it is. I don't even know. But they were off by 14 feet, okay? So if you're looking at the aerial view of this, here's this like river thing going on right here, right? Okay? And they're building it on this side, and they're building it on this side, and they were off by 14 feet here. So guess what they had to do? Tear down one side and build it again. That stinks. Yeah, just make like a little like, you want to do that?
Yeah.
That's just like a little intersection where you veer off. Yeah. Real bad, right? Yeah. I'll have to look it up. Yeah. So they screwed up on their calculations. It involved a lot more than proportions, right? It was like trig stuff, like sine, cosine, tangent, that type of thing. Try to figure out where they meet in the middle. And somebody did not do a very good job. So, legit, they do this. Okay? All right. Even though we have a long class period, I don't want you guys to be too far ahead of the other class, so how about we just stop and we'll do Pythagorean theorem tomorrow. Because I have fun stuff with Pythagorean theorem. Okay? So, keep this note sheet for tomorrow because we'll finish the backside, right? Okay? So you won't need to pick up a note sheet, but you will have a quiz over this stuff, right? As always, right? Right? Okay. Everybody say, bye, Lacey!
Bye, Lacey.
Oh, you guys are awful.
Hey, that was bad because I thought that was, he just got like hated on.